project-by-project improvement. When CEOs aim to enhance their company's quality, they often make grand declarations like, "We will invest in our people. Every one of our 1,000 employees will be trained to improve quality as part of our continuous improvement program." Once you've completed the training, you'll be able to improve quality in your daily work. Good luck. These statements sound promising, but the reality is often disappointing. After all the training and enthusiasm, there's little to show for it. Perhaps a minor improvement if you're fortunate, but typically, everyone simply returns to their usual routines. Unfortunately, this scenario is all too common in many organizations. Quality improvement shouldn't be handled this way. It should be approached through structured projects, efforts with clear missions, specific goals, and defined scopes, led by dedicated teams and concluded when their objectives are met. The late quality expert Dr. Joseph M. Juran strongly advocated for this project-based approach, famously stating, "All improvement happens project by project and in no other way." In his 1986 Quality Trilogy presentation at the American Society for Quality's annual Quality Congress, Juran outlined the quality improvement process using a project-focused methodology. The steps include proving the need for improvement, identifying specific projects, organizing teams to guide the projects, diagnosing causes, implementing remedies, and ensuring the effectiveness of these remedies. This method closely aligns with the DMAIC process used in Six Sigma. For more insights into DMAIC, consider exploring Six Sigma Foundations and Six Sigma Green Belt courses on LinkedIn Learning. Today, these principles are integral to various quality improvement strategies, particularly Six Sigma. For example, the initial steps of quality improvement are mirrored in Six Sigma's COPQ, project selection, and define phase. You can clearly see how each step in Juran's approach corresponds to phases in DMAIC. This project-based methodology is targeted and precise, much like a strategic operation, ensuring that quality improvement is focused, effective, and impactful. Root cause analysis. When you visit a doctor because you're feeling unwell, the process often starts with analyzing your symptoms. If you have a high fever, for example, the doctor will consider possible causes and might order tests to confirm the diagnosis. Based on the test results, the doctor will either confirm the initial diagnosis or explore other possibilities with additional tests. This process mirrors root cause analysis in quality management. You start by identifying the symptoms of a problem, hypothesize potential causes, and then use data to validate these hypotheses. Let's break it down. First, analyze the symptoms using various graphs and charts. This helps you gain a deeper understanding of the problem and identify if it's a recurring issue or a one-off incident. For minor, isolated events, a full root cause analysis might not be necessary. Simple troubleshooting may suffice. For instance, if a delivery delay was caused by an unexpected roadblock, you can address it directly without further investigation. However, when patterns of failure emerge, it's time to dive deeper into root cause analysis. Begin by focusing on the most critical areas using the appropriate tools based on your data type. If you're working with count data like defect numbers, a Pareto chart can highlight key areas to investigate. For continuous data, such as processing times, box plots or histograms are more suitable. Once you've pinpointed where to concentrate your efforts, clearly define the problem in measurable terms. Next, involve the people closest to the issue, operators, engineers, and other subject matter experts, by conducting a focus group or workshop. Start by brainstorming potential causes and organizing them into a cause and effect diagram. Use techniques like multi-voting to narrow down the list to the most likely causes. But remember, this is just the beginning. Now, it's crucial to validate these causes with data through hypothesis testing. Employ statistical tools like two-sample t-tests, ANOVA, or chi-square tests to confirm or rule out potential causes. This step is essential. Without it, you risk basing your conclusions on assumptions rather than evidence. The integrity of your root cause analysis hinges on data-backed validation. In many companies, the root cause analysis process stops prematurely after reaching a consensus on likely causes. However, a vote isn't proof. To accurately identify the root cause, rely on data, not just opinions. Always ask for the data. It's the foundation of sound root cause analysis. Six Sigma DMAIC. Six Sigma DMAIC, along with Lean Six Sigma, has become a cornerstone methodology for quality improvement over the past 25 years. As previously mentioned, DMAIC is essentially a structured implementation of the quality improvement process outlined in the Quality Trilogy. But what exactly does Six Sigma entail? Six Sigma DMAIC is a project-based framework designed to minimize variation and enhance quality. It emphasizes a disciplined, customer-centric, and data-driven approach to refining processes, products, or services. Unlike traditional methods that rely heavily on detection and inspection, Six Sigma DMAIC focuses on prevention and control. To dive deeper into Six Sigma, it's advisable to begin with the Six Sigma Foundations course and progress to the Six Sigma Black Belt course, as part of the Becoming a Six Sigma Black Belt learning path, available on LinkedIn Learning. Additionally, the How to Manage Lean Six Sigma Projects course offers valuable insights into the practical application of this methodology. Six Sigma DMAIC is a highly structured approach. With each of its 5 phases: define, measure, analyze, improve, and control, clearly delineating the steps, tools, techniques, and expected outcomes. In the define phase, the project's scope is outlined, and a suitable team is assembled. The performance gap or desired outcome is clearly specified, focusing on identifying the output variable, y, which is dependent on various input factors, x's. This targeted approach ensures projects remain focused, on budget, and within scope. During the measure phase, data collection and analysis help quantify the extent of the performance issue. Key areas are identified to hone in on during the subsequent diagnosis. In the analyze phase, the team investigates these focal points to uncover the root causes, the critical X's, that influence the outcome. Why these causes are validated using hypothesis testing and data analysis. In the improve phase, solutions are crafted to address the root causes, optimizing the factors that influence the outcome Y. The aim is to identify the most effective combination of solutions that will meet the project's objectives. Finally, in the control phase, mechanisms are put in place to ensure the sustainability of the improved performance, maintaining the gains by keeping the key X's in check. In summary, Six Sigma DMAIC transforms quality management from a reactive, inspection-based approach to a proactive, control-focused strategy. By managing and controlling the key factors, X's, organizations can consistently achieve the desired outcomes, Y, much like ensuring perfectly baked cookies by controlling oven temperature and bake time. This approach underscores the essence of Six Sigma DMAIC. Supplier quality management. In many companies, purchased materials can account for up to 75% of the cost of goods sold, making the quality of these materials and components crucial to the final product or service. The saying, "You're only as strong as your weakest link," is particularly relevant here, as the quality of supplied materials directly impacts the customer experience. Traditionally, companies have relied on incoming inspections to ensure the quality of materials and components. However, modern quality management practices emphasize quality at the source, meaning that quality is assured where the work is performed, preventing defects from reaching the next stage of production or the customer. Quality at the source applies not just internally, but also to suppliers. Ensuring supplier quality involves a range of practices. First, Suppliers should implement error-proofing methods like poka-yoke to minimize the risk of quality failures. Additionally, it's important to assess the supplier's process capabilities through metrics like CP and CPK. If these indicators fall short, quality improvement projects should be initiated, potentially involving process capability studies at the supplier's facility. Process monitoring and control should also be in place, particularly for processes that affect critical product characteristics. Self-checks and in-process verification by suppliers can further reduce downstream quality issues, and all inspections should use validated measurement systems, with measurement system analysis, MSA, results evaluated as needed. Product testing, whether conducted in-house or by third parties, is essential to meeting regulatory standards. Supplier audits should go beyond product audits to include process and quality system audits, ensuring that the supplier's operations can consistently produce defect-free products. Effective audits can reduce or eliminate the need for inspections upon receipt, enabling just-in-time deliveries directly to production lines. While quality system audits are important, they should not be the sole method of managing supplier quality, as they focus on procedures rather than the quality of products or processes. Instead, these audits should complement other quality management practices. Given the scope of supplier quality management, it's wise to prioritize key suppliers who have the greatest impact on your product's quality. Ultimately, while incoming inspections have their place, true quality assurance requires managing quality at the source. As your organization strives for operational excellence, remember that your suppliers are integral to that journey. Quality Management System, QMS, navigating the numerous tools, techniques, and processes involved in quality management can feel overwhelming. Wouldn't it be helpful to have a system that organizes and integrates all these elements, allowing you to formalize and control your approach to quality management? The solution is a Quality Management System, QMS. A QMS, as defined by the American Society for Quality, is a formalized framework that documents the processes, procedures, and responsibilities necessary to achieve quality objectives. It helps align and direct an organization's activities to meet customer and regulatory requirements while improving efficiency and effectiveness over time. A typical QMS is structured into several tiers. First, you have quality policies, which outline the organization's approach to quality management, the why behind it. Next are quality procedures, or SOPs, which operationalize these policies by specifying what needs to be done, by whom, and by when. Then come work instructions, which provide the how, detailing the steps to implement these procedures. Finally, quality records serve as documented evidence that the QMS is being followed, ensuring compliance with established policies and procedures. These records could include batch records or engineering change orders, among others. A QMS should not be limited to just text. It can also include diagrams, charts, photos, and videos to enhance clarity and usability. To maintain compliance and effectiveness, regular quality system audits are essential. These audits not only ensure that the QMS aligns with documented procedures but also evaluate its continued relevance and effectiveness in meeting quality standards. For organizations seeking certification, such as ISO 9001, these audits should also assess compliance with international standards. It's important to design your QMS with your company's specific needs in mind first, rather than focusing solely on certification. This approach minimizes the risk of creating bloated, inefficient processes that, while compliant, may not serve your organization's goals effectively. A well-designed QMS should be both user-friendly and tailored to your company's requirements, ensuring that it supports productivity and quality leadership, rather than hindering it. Always consider the voice of the customer, and remember, your employees are customers of the QMS too. A system that is cumbersome or overly complex won't be used effectively, so it's crucial to make it as practical and accessible as possible. Ultimately, the goal is to create a QMS that not only meets compliance standards but also drives your organization toward excellence in quality management. Conclusion: enable, empower, and encourage achieving operational excellence through quality management requires a quality management system, QMS, that remains effective over time. But why is this important? And how can it be achieved? Effective quality management empowers employees to perform their tasks efficiently, and with a robust performance management system, it fosters operational excellence. Let's delve into 3 critical aspects: enable, empower, and encourage. To enable employees means establishing processes that are not only well-defined but also capable of allowing employees to perform their tasks with ease and precision. This includes ensuring that the processes have the necessary capability to meet specifications, along with the right technology, equipment, staffing, and training. These factors maintain a high level of process capability, ensuring consistent execution with minimal variation. Essentially, a well-designed QMS demands capable processes that enable employees to achieve the desired performance consistently. Next, to empower employees involves giving them the authority to execute their work as outlined in the QMS. True empowerment goes beyond verbal permissions. It requires formal delegation of authority within the quality procedures. For instance, production line operators should have the authority, clearly documented in standard operating procedures, SOPs, to halt production if defects are detected. This formalization ensures that empowerment is maintained even as staff or management changes, providing a consistent framework for employees to take action with confidence. Finally, to encourage employees means aligning their goals with the organization's metrics, such as process metrics, quality KPIs, and reward systems. This alignment should be organization-wide, ensuring that everyone is working towards the same quality outcomes, not just in the present but sustainably into the future. By fostering an environment where employees are encouraged to collaborate towards common goals, the QMS supports continuous improvement and long-term success. In conclusion, a successful QMS is one that is designed to enable, empower, and encourage employees to excel, thereby driving operational excellence. For a deeper understanding, consider exploring the LinkedIn Learning course, Driving Measurable, Sustainable Change. Next steps: congratulations on completing this course. While we've only touched on the basics of quality management concepts, tools, and techniques, it's important to recognize that quality management is a vast field with much more to explore. You could spend years delving into the subject, but even a foundational understanding can be incredibly valuable right away. I hope this course has provided you with a solid grasp of quality management and its role in achieving operational excellence. You might be excited to dive deeper into the various quality concepts, tools, and techniques introduced here. Remember, each topic we've covered could be a full course on its own. For instance, take a look at some example topics beside me: cost of quality, SPC, supplier quality, quality auditing, and many other essential tools. If any of these topics catch your interest, or if there are others you're curious about, please jot them down in the Q&A section below. I can share additional resources or even consider developing a new course on the topic. Your feedback is invaluable. As you move forward, you might consider pursuing professional certifications like Certified Quality Engineer, CQE, or Certified Manager of Quality, Organizational Excellence, CMQ-OE. Whether your goal is to deepen your understanding of quality management or to prepare for certification, I hope you found this course both enjoyable and informative. Wishing you all the best on your journey to mastering quality management.